Okay, so this is just kind of, I did a little bit of research and this is a little bit that I understood about it, but just to kind of take you through it. Let's say hypothetically you take a survey and your response rate for males and females, let's say your response rate is 45 and 55, that's your percentages.
Yeah.
Yeah. And let's say hypothetically that you know that the population average is, or the population ratios are, let's say 48 and 52%. So then the question is, how much do I down weight this survey response so that it matches 52%? And how much do I up weight this survey response so that it matches a population average of 48%?
Yeah.
And that's the whole idea behind this rim weight situation. And I don't know math. Oh, God, I should just know this, but is it take this and divide it by that?
Yeah.
Something along those lines where you say, okay, take your survey response. How much do you like soda?
Yeah.
I like soda 4 and they like soda 3. And then I'll multiply 4 times 1.066 to, ooh, that's not true. That's not true. But the idea is you'll add a multiplier to readjust the weights. And the part that makes it a little bit even more complicated, and I don't necessarily know that this is represented in the proof of concept that I built, is that you say, okay, well, we know the multiplier to apply if you just have 2 variables or 1 variable, but what happens if you have 2 variables? So let's say your question is, what is your distribution of jobs? Yeah. And you have job A, job B, job C. We know that the survey representation, our survey response was 0.33, 0.5, and 0.27.
Yeah.
And we know that the population average is 0.45, 0.32, and I don't know math. Okay, so we know this is what it should be. And again, we'll calculate these weightings, but you can't just apply this to a number. You actually have to now come up with 6 combinations because there's 6 permutations of males in job A, females in job A, males in job B, females in job B, right? So there's 6 different weights that we now have to apply.
And I guess that in that scenario, that's where it needs to be ideally dynamic on the fly, right? If you cut the data on a question to filter it by these different...
I don't know. So what I implemented for you in the R script was to say, okay, the user will
all the
have
combinations,
to,
right?
Yeah, the user will have to define, okay, I want to be able to adjust my model for male and female, or I want to adjust my model for male, female, and job, or maybe this other factor. And basically, in the survey results, we had weight for just adjusting gender. And then we had another column for weight to adjust gender and job. And then you would have another column for just weight for job, and another column for weight for job, gender, and blah, blah, blah. But this bit here would require some non-trivial R scripting.
Yeah.
So you can't run it for every single possible variable that what we've implemented so far, they would have to define and know in advance which combinations they want to adjust for. And I don't think that's unreasonable.
Yeah.
I don't think that's unreasonable. And, you know, if they have people who can write .NET, I'm sure they have access to people who can write R or do it in Excel or do it in SPSS and replace the data set. That's not the hard part.